Right. Hey, welcome everybody. Hey, it's the CNCF Tag Network meeting it's the first one of December. So December 2nd, Thursday, December 2nd. Nice to see a lot of you on. We were just getting the meeting minutes all prepped. I think we've got a number of topics, or I know that we do. Now's the time though, as you look over the topics, to go ahead and drop in any additions, also to drop in your name. Good to have everybody on the call. I'm hoping we'll have a couple of other folks join. If not, we'll have some incomplete action items. As we get going, just some housekeeping notes. One, this is a CNCF call. And so, be nice to your neighbor and don't say things that your mother wouldn't approve of. We'll post it on YouTube, even if you do. My name is Lee Calcote. I'm one of the co-chairs of the Tag Network. In this in Tag Network topics, we talk about service mesh working group as well. But as I was saying, I'm one of 3 co-chairs that helps steward activities here. The other 2 are on the call, and I'll let Ken and then Ed say hi.
Okay, I'll go first because I'm apparently unmuted. Hi, I'm Ed.
All right.
Hi, I am Ken. I'm on another call with work, so it's running over as always. They seem to do, but I'll be off this other call in a few minutes. But nice to meet you guys.
Oh, very good. And then, as a young tradition, but a tradition nonetheless, would have it, Zachary, you might be our winner today. Anyone who hasn't been on the call before has the fortune of taking a moment just to say hi, introduce yourself, and what's got you hanging out with us today.
Definitely. Hi, yeah, I'm Zach. I'm an SRE at Peloton, and right now, one of the things we're looking into is adopting service mesh internally. So I know you all talk about that a lot here. So just here to, kind of stay on the edge of what you all are doing and see how it can help us in the long term.
Zach, very nice to have you. Hey, you've come to the right place.
Perfect.
Feel free to interject at any given moment or to be as small of a fly on the wall as you so choose. And so, by the way, just before I what's the right word? Is it Zachary or is it Zach?
I go by Zach normally, but either side.
Okay. Nice. Anyone else on the call for the first time today? Nope. No. All right. Well, so the sequence of that we chew through agenda items is we start with any Tag Network topics. Commonly, these topics include a review, like a project review. It's worth taking a moment briefly. Our last project that we reviewed was Fab Edge, and there's been, I think, a very nominal amount of chatter ongoing about the project. And so I figured I'd ask Ed or Ken if there was anything of note, just in terms of next steps or comments from that project. They were up for review. They'd gotten some feedback.
Yeah, so my understanding is that they were for review. There was a little bit of confusion around some items. There was some feedback and questions. My counsel was to update their slides to respond to the feedback and questions because they actually had relatively good answers to the issues that were raised. They just weren't obvious from their slide deck. And so they have reported that they've done so.
Nice. Yeah.
It's always really hard to predict what the talk is going to be interested in. So you can't always get all the things in the slide up front.
it's good. Yeah. Nice. Good. Yeah. I suppose they're good. They're, if they were to ask, just to the extent that this isn't popularly known, their recourse then is, well, either they can come and hang out here and get some more feedback and kind of, or they can resubmit for evaluation by the TOC. My hunch is if they go and do that, directly, that they may find that they'll face the similar set of questions from the TOC. And so, I don't know. Yeah, I don't know.
Yeah, so the questions the TOC asked were good. It just, there wasn't any clear answer at the time they were doing the evaluation. So I think the TOC might potentially be open if they could get the feedback information they're looking for. Because they were questions like, why not be part of CubeEdge? Which is a completely valid question, and they had a really good answer for it. So.
Okay. Anything else on the topic of FabEdge? Nice. All right, into Service Mesh Working Group topics. Hey, actually, I ask either Sunku or Navendu, if either of the two of you wouldn't mind, would one of you ping Jing Hong in case he's around? It'd be great to.
He mentioned that it is really late for him to join, so
Wimp.
he.
No, yeah, okay, all right, fair enough. I know he's engaged on these efforts, and so okay, thank you for that. So KubeCon China is coming up, and actually this is a topic for the TAG network. So there's a session, an intro and deep dive to things that happen here, and there's a fairly decent recap of what has transpired. Primarily, like the deep dive ends up being on projects and initiatives and their progress since the last KubeCon. And so Ken had a number of things to say in this update. So the deck is kind of posted out there early. I encourage folks to go check it out. There's a couple of statistics that I think are interesting. Ken, anything else that you might want to add on with respect to the talk?
I think the best thing about the talk was we really focused on just how much we've evolved as a tag group over the last 3 years, and kind of looking back at how much we've accomplished. It's easy to kind of say this doesn't matter, but when you look at what we've accomplished over the last 3 years, it was really good to see that we've grown a lot and we're continuing to grow, which is really good. Maybe next time Ed will be able to join us. It would have been fun to have Ed on there talking with us. We would have.
Yeah, I do apologize for that. It's been a little crazy over here. I've had some releases going out, so.
It's also, I'm also a lot of my lack of organization skills are probably at significant fault for missing Ed. Okay,
that's okay. I'm no great shakes at organizational skills myself. So
okay. So of the other topics that we have on Service Mesh Working Group, there are about 3 projects that we focus on a fair bit. So one of them is Service Mesh Performance, Meshery, and Nighthawk. Meshery and Service Mesh Performance as projects are recent entrants into the CNCF. And so each of those 2 projects have project office hours. Both of them just had their office hours assigned yesterday. And so there'll be emails going out on those lists to point people to those office hours. So that's great. Sunku, do you interact with Jing much?
No, actually, we both are in different teams as such, so hadn't had a chance to interact with him.
Okay. Are you Wait, are you saying Intel is a big place? Is that what you're saying?
Yeah. Yeah, if you don't already, yes, it is.
Okay. All right, fair enough.
I have great sympathy with that coming from another big place.
Yeah.
Yeah.
Yeah, I mean, I do see his conversation, so I hadn't, I mean, I see his part of the service mesh enabling team, like Nitika responded. So they work on actual enabling of service mesh code. So our team's focus wants to be in leveraging service mesh for 5G and edge computing. But yeah, so we hadn't had a chance to discuss with him yet.
Very good. If you would give, the reason I ask is if you would give consideration to this, he'd been engaging in getting some of these benchmarks going, and I had suggested to him that by the time he's done a few of those things, he might like to join us in the project office hours as just as another person to help discuss the activities of what's going on. If you would give that some thought and let me know how that strikes you.
I think it's definitely a good idea. So you could get to see the initiatives that the team is working on. We could bring in the new perspective from his side, especially for the office hours in Cube China.
Nice. Okay. Yeah. Good. One of the first topics up is really the same topic. It's about performance benchmarking. It's about trying to accomplish some of the larger goals that were set out for service mesh performance as a project much during its genesis. And it is, a lot of that's about informing the world of like concerns around performance when you turn on various things inside of a mesh, understanding the value that you glean, understanding the performance impacts to the various features and functions, the different ways that you're configuring your mesh. And the tooling is in place to go run a litany of tests. There's automation now in place to run tests. Some of that automation has begun. And so there's a couple of folks on the call. Navendu, do you want to speak to this?
Yep, sure. Maybe I can show like what we're talking about as well to get some idea. Let me try to find the screen. Oh, wait.
So as a precursor to this of what we're, Sunku, I think one of the reasons that I'm enthralled that Jing is engaging is that I think he may be able to bring some time and a bit of muscle to actually running a number of these tests inside of dedicated, inside of the CNCF labs. Of what Navendu is about to show, I think, is some of these same tests running using GitHub runners, GitHub hosted runners. And we should discuss on this call how we can potentially use that same action, that same automation, but use different self-hosted runners, which if you think about it, that might mean that we could then use the same automation, use the same actions, which have a number of, well, I'll let Navendu show it and then we'll talk about the CNCF labs.
Yep. I'll share my screen. Yep. So I think we have talked about this action a bit on the previous calls, but what we have essentially here is a GitHub workflow that automatically runs performance benchmarks on service meshes. So we are scheduled to run every day. So we we test multiple service meshes. We have Istio and Linkerd, and we use multiple load generators for Theo and WRK2. So we also have some more other configurations. But yeah, just for the sake of this demo, I have run this test a while back. And what we can do here is we actually collect these results that which we run in the GitHub hosted runners, and we have it in Meshery. So we have been running this test for quite a while now. So we have collected a large number of tests, and yeah, like one area that I have pointed out in the meeting minutes was to actually define the test configuration. And so Sunku and Zin was already looking into how we can actually define those test configurations. So we have these test configuration defined in a YAML file. So basically, this YAML file contains the entire configuration of what each test should look like. So we can basically have multiple test configuration. Let's say we can have a load test, and we can also have a soak test, which runs for a really long time. So we can have these multiple configurations. So one such ask here and one such area for people to get involved is to actually help define these test configurations. So yeah, like and yeah, like we also so I was just debugging some issues, but basically we have been running a lot of these tests, and yeah, like we hope to add the other service meshes as well. And we also hope to or we are also in the process of designing a dashboard uh, which is which can be made public, so that people can come in and see how all the different service meshes compare with each other, and what are the benchmark scores for these each service meshes, and with what kind of workloads and all those stuff. So yep. Any questions or?
So, Navinder, yeah, thanks for doing this. So this is a really good start to get this going. So in terms of the test profiles, right? I mean, there are various ways we can look at this, right? Scaling, or single node, or running as inside a virtual machine, running on bare metal, etc. Different ways of I mean, dividing the tests. So is there any specific priority or order how we are considering this? Is there any plan towards how we are planning to approach this?
Yeah, I guess the initial plan was to get this running on GitHub hosted runner and then move on to CNCF's machines. I'm not sure, like I don't have the exact configuration of what the CNCF hosted runners look like. Maybe like someone else on the call might be able to provide some insight into that.
Yeah, the CNCF labs used to be offered by Packet, and that is since some while ago moved over to, oh boy, what is the name escape me? It starts with an E. Didn't they just get acquired?
Equinix. They're now Equinix Metal.
Okay, yeah.
Which is a very cool name.
And yeah, and so the particulars that I recall from Packet probably have no bearing or weight on what bare metal machines are available through Equinix Metal.
It's actually almost exactly, it's a very smooth forward evolution. So other than the fact that when you go to packet.net, it redirects you to the Equinix Metal page, the APIs are consistent. It's still using Tinkerbell in the background. We, in Network Service Mesh, we were using them through the transition of their acquisition, and there wasn't a single blip. It just worked. So whatever it is you think you know about Packet, modulo naming, it's almost certainly exactly the same.
In the NSA, in the Network Service Mesh project, as you guys are using Tinkerbell, does Tinkerbell inclusive? How difficult is it to get a Kubernetes cluster up and going.
So just by way of clarification, so Tinkerbell is literally the software they're using to run Equinix Metal and have been using since it was Packet. Now, the fundamental question you're asking though, which is how easy is it to get a cluster up and going? It's actually very easy. Currently, we're using their Terraform bindings to stand up the servers, and they're just running kubeadm to stand up the cluster. And I think it takes us approximately 5 minutes to get a cluster going. So not bad at all. But the other thing to keep in mind is that they're in the middle of the transition to the cluster API. And so last time I checked, they are still using the pre 1.0 APIs in their implementation of cluster API. And so you would have to use an older version of cluster control. But I would strongly recommend going and checking, because you may find that cluster control is your way to happiness there, because they may have actually caught up with the API shift.
Is time contentious on, or have you found time in the labs to be contentious?
Not generally.
Okay.
I mean, the reason it's not generally contentious is that it's not labs in the traditional sense. What it is effectively is the provision of credits by Packet, now Equinix Metal, for CNCF for use by CNCF projects. And so the net is, we're not operating from some like pool of reserve instances, generally speaking. We're operating from the, hey, I need this flavor metal box. Do you have one? And generally speaking, they do.
Nice. Okay.
Yeah. That said, of course, be hospitable about cleaning up after yourself. So, make sure that you're actually correctly reaping the metal boxes that you grab. We want to be, appreciative of their kindness and not abuse it. So do make sure to be scrupulous about cleaning up after yourself.
Have you heard are you aware of anyone using, self-hosted runners from GitHub workflows using Equinix Metal as self-hosted runners? I imagine there wouldn't be an issue. But...
So I wouldn't expect there to be an issue. I haven't personally done that or been close to people doing that. But the other thing I would point out is that Equinix Metal has its own Slack, and they're super friendly and helpful. So if you sort of pop up and say, hey, is anybody mumble, you'll probably get somebody who will respond.
Very good at taking note.
Yeah, it's been a really, really positive experience overall.
Very good. And then Zach, I was just posing a question here. It's in part to Sunku's exact question, which he was sort of asking, like, hey, so this is great. This is a great start. There's tooling, like we're ready to go off and kind of do a bunch of testing in a big way. Part of that testing is either just putting some blinders on and saying, hey, well, we'll run a sample application that looks like this and look like this, and we'll do it under this much load or for this long, or we'll do it on a super tiny cluster or a really large cluster. And I think all of the tests are valid to the extent that someone somewhere out there runs something kind of similar, like to the, and so, yeah, any amount, understanding that you all are pre-service mesh, just having some sense of, well, I don't want to pry, but maybe the right thing to do is like propose a few different configurations and have you emphasize the ones that might be of it. Like if you were to see the results for those, what might be of interest to you? We're trying to make sure that we're curating the right data. We're measuring in the way in which would be interesting to people.
I think, and maybe you already have this covered, and if you do, let me know. Are most of these tests like baseline tests where you just have a single application in the mesh that you're hitting with load, or do you have, let's say, like a set of 5 applications that might communicate with each other so that you could actually configure quote more real world microservices, so where we could see, if there's 3 or 4 hops before the request like comes back out to a user, if that has any impact on performance, that would be super helpful for us. I'm sure having like a baseline, kind of like what each service mesh can do, is really helpful for you all to just establish that baseline. But for us, that would be more of like a real world use case.
Nice. Yeah. Yes is the answer to your question about the sample applications that are being used being like a collection of microservices that yeah, when you poke the first one, that they have upstream services that they need to call, and you mentioned something in there though, like the word baseline, that had me realizing that what was something Sunku and Navendu and Nirvan and everyone else, something that we don't necessarily highlight or discuss a lot, but it's almost, I got to imagine, or at least like I've been asked this any number of hundreds of times. The first question is just like, what's the difference between being on the mesh and off the mesh, irrespective of, and so that might be something to infuse, potentially, I don't know, that into each type of the test, like that, or maybe I should say for each workload that's used as an example workload, that the testing of those should first include a deployment of that workload off the mesh, and then the testing on the mesh. And yeah, because it's just one of those, it just provides some immediate insight into the thing about the differences between being on the mesh and off the mesh is like, you'll see a dramatic, you can see very nominal changes in the performance. Or you can see dramatic changes depending upon like how much you're asking the mesh to do. And so when we present that to people, yeah, part of like curating these dashboards to help let people know what they're looking at, that before they just kind of took a quick glance and then run off and assume that there's a whole bunch of overhead, or that there's no overhead depending upon which chart they're looking at. So Zach, let me see if I can, yeah, this is like, do you know in your environment, do you guys today, do you do performance testing today? Like if you do, is it just, quick little tests, or is it like you're going to do a new rollout of your, the next version of your services, and you let it bake for like a week or something like?
Yeah, I think it depends on the scenario. Like most teams are doing some amount of load testing, and then I think they can mostly configure that like for their use case, or like if they knew there was like a big change that like might impact something, that might run longer tests or things like that. I mean, one thing we're gonna have to do as a platform team for our own due diligence is just, as we present this to teams, say like, hey, you come on the mesh, here's kind of like baseline what we know it's going to introduce latency wise. So if, like you were just saying, if you had that
yeah,
kind of in a general way, that would just be a helpful starting place too.
Yeah, one thing we have done along these lines is maybe it's a good point that we need to do before service mesh, after a particular service mesh, but within service mesh to understand, for example, right? So simple web server like Nginx web server, understand its impact between a load generator and the one particular part which is running a web server. now, but towards really scaling these applications and testing the distributed setup, right? So now you can use something like Desktop Bench or Google Boutique, microservices, etc. And then, which is where the east-west and north-south, all of these communication performance come into play, right? So that's another way of looking at it. So essentially, I think from a test case perspective, we could look at similar set of applications without service mesh and do the same with service mesh. If we could narrow down on one particular application suite and try and leverage that for multiple set of tests.
So Sunku, think about this. How do we make the rubber meet the road on some of this? So we're
so, yeah, there is a lot of tests being done in Intel, for example, using Desktop Bench and identifying bottlenecks and understanding what's the right way to go about it to scale in particularly with service mesh. Right, so I'm not sure if you can share the results that I know of, but yeah, that's a pretty popular application under consideration. So in terms of what would help the community, right? So we need to find a workload that's representative of, so what the production use case might be, or a realistic use case might be. For example, have a database, have a web server, have an application that responds, something along those lines, right? So maybe you can come up with a minimal set of components that are necessary and say, hey, these are the set of services we need that are deployed in a service mesh, and then probably benchmark that.
So we have those. So I'll ask again. Yeah, very good. Makes sense. Yeah, but we have those.
Okay.
And I guess like making the rubber meet,
Actual work.
Yeah.
Mm-hmm.
Which is so the tests are now schedulable. I guess so. We've got 4 or 5 different sample apps. This is one of them. This online boutique. Yeah. I don't know. I guess it's kind of like we were talking about last. Like we're just gonna start. Actually, I'll go as an action item. I'll go message with the. I'll go send out some emails, more or less asking some of the same questions that I was just prodding Zach on, and see if people have opinions, or as we describe the sample apps that we might use, we'll see if they, if those are like of the Desktop Bench, that app that you were just referring to, is that, is that close in nature to any of these sample apps?
Yeah, I think Desktop Bench possibly would be similar to the Google Boutique with a set of microservices. I think Desktop Bench, I believe, was originally created by Carnegie Mellon for research purposes, and it's gotten some popularity.
Oh, yeah, Desktop Bench. I see.
Yeah, and yes, it's I think it's a similar set of services to Google Boutique.
Oh, okay. Yeah. Gotcha. Yeah. Okay.
The reality of these using these apps, though, since they're not necessarily designed for high performance, like scalable type of infrastructure, at some point you can find bottlenecks with these type of deployments that are independent of the underlying hardware, underlying infrastructure, underlying mesh. Like when we scale, they're only, if we use one instance of sample web server, it can only service so much, right? So from that sense, there are bottlenecks per se, going with the default versions. But it's up to us to see, we want to modify these services to scale it to address our performance testing needs, or just go with whatever's the default. That can be second step, but we need to start with something, so to say.
Ed, question for you. As we go to run these tests, network service mesh is one of the meshes that we'd like to put under test. I don't think it's going to be a fair comparison, if I can use the word fair.
Well, I mean, it's not about fair or not fair. It's really about network service mesh being complementary to application service mesh. So network service mesh doesn't even try to do HTTP stuff because there's lots of people in that space doing it really well, right? But what we do that nobody else is trying to do is we will allow you to carry other kinds of payloads like L3 payloads in a mesh style approach across multiple clouds, multiple locations, et cetera. So you can have pods running in a bunch of different clusters in a bunch of different places that can be receiving a common network service that you could run any number of things, including a service mesh over. So, I mean, I think we're getting to the point shortly where we're hoping to have the use case of running a single service mesh over a VL3, which can span multiple clouds. So you could just have, instead of having a bunch of gateways, you would have just a single instance of your service mesh and you can have pods running wherever. When we get to that point, I think that becomes a very interesting case for mesh ready to test, because obviously the question is, okay, so like what is the behavior like when you smear a service mesh across GK, AKS, and EKS and some on-prem stuff as a single service mesh, not as a thing where you've got a bunch of crazy gateways going on and static routes, but as a single service mesh.
Yeah, that's a good call out. Yeah, I agree. How does and you use the right word, like behavior. How does the behavior change?
Well, I mean, you've always got to watch out for implicit assumptions. And network service mesh solves several of them, but it'll be interesting to see what others there are.
Okay.
So along those lines, Ed, from a network service mesh perspective, are there today any type of performance tests being run or being published that are available publicly?
Not currently. Now, there are two things to be aware of with that. One of them is that obviously when you start playing serious performance games, you end up having to tweak things a bit, right? So if you deal with anyone who's actually, and this is not so much of an issue when you're talking about L7 stuff, right? Because compared to what you have to do to process packets, L7 is so slow, it just doesn't matter.
Yeah.
And that's fine, right? But so there are things you would want to consider if you were going to do actual performance, if you were actually going to tweak for performance. Right now, if you just go run our examples, they're actually optimized to run everywhere, which is actually the right answer for many people. But if, for example, you had somebody who wanted to do, say, for example, NFV use cases, which we've got folks doing, those folks are going to want to configure some stuff. Now, from a performance point of view, we do have sort of a lot of the data planes that are in use tend to be either VPP, VPP data planes, or things that are taking advantage of SmartNIC functionality or SRIOV. And so we know the underlying things that process packets are crazy fast. So for example, VPP has been clocked at a terabit per second of IPsec on a commodity server with no more accelerating hardware than sort of traditional RSS queues. So we're feeling fairly good about the fact that the actual bottleneck you're going to see is not going to be network service mesh. It's going to be the kernel's TCP stack, which is, again, and this is all about where you sit in the world. If you're actually a hardcore network person, the kernel's TCP stack is really slow.
Yeah.
So, but no, feel free to ping me on Slack if you've got specifics you'd like to talk about. Because I could talk about the stuff far more than is appropriate for this call.
Yeah, no, definitely. I mean, some of these things I've been working on, so yeah, definitely resonate with me. I guess the idea or question is more like, although we have underlying accelerators, software-based user plane stacks, or even kernel stacks, right? So how does NSM kind of impact, right? So is there minimal impact? Is it impact latency? So things along those lines to see, is it just configuration time? We don't have to worry about at the actual runtime in terms of data plane performance, right? So if there's any general guidance that's available, that's a good one. Or if not, even, I mean, maybe this is a good forum that we could consider looking into some of these things running in automated fashion.
Yeah, I mean, I would love to get a little more input from you on what you would be looking for there. And as I said, getting that up and running in an automated fashion is definitely on our list. You know, one of the things that I'm currently trying to shake out is, again, when you're dealing with the L3 stuff, it's so many orders of magnitude faster than the L7 stuff that you need things like T-Rex to drive traffic in a meaningful way. That's actually interesting, because IPperf is just frankly not up at that level. But yeah, so that is actually on our forward going list, is getting some of that going. And part of it also is we adopt a general strategy of putting everything on our CI chain. So that's something we would want to bring up on CI on Packet in order to sort of get that up and running and looked at. The other thing that we're in the process of doing that makes that interesting is, if you're talking about performance of anything, fundamentally the bottleneck is always going to be the NIC that leaves the box, the physical NIC leaving the box. And in our run anywhere mode, we opportunistically grafted onto that with AF Packet, which, if you're familiar with that sort of stuff, it's reasonable, but not fantastic performance-wise, but it will always work. We're looking at being able to, if you decide to run it with something like the VPP-based Calico, which means that we would be sharing a VPP that owns the hardware NIC, which would give you much faster performance. Because now you're talking about, you know, the fast path and moving into the realm where you're getting that kind of terabit style performance.
Yeah, no, makes sense. And definitely our team is looking into NSM for a few of these cases. So get back to you on the use cases.
So,
yeah.
Please ping me on the CNCF Slack. We'll get stuff sorted out. The NSM community is very responsive to sort of downstream consumers who are looking at stuff and what they want to see. So please do reach out.
Absolutely, thank you. Yeah, along those lines, Lee, I think you know, to your point, like measuring and testing NSM is way different, like Ed mentioned, compared to, you know, FOTA.io based or Nighthawk based, you know, service mesh testing. It can need different set of traffic generators, different way of looking at the entire testing compared to layer 7.
And so to back to Ed's point that, like, yeah, when there are other service meshes running on top of NSM, that becomes a great use case, especially test case.
Yeah, that would be
one that I actually, and one that I would actually expect to go relatively well architecturally, because the traditional service mesh model is, you know, you push config out to a thing that's actually your ingress, like an Envoy sidecar that's learning really, really close to the workload. So I would expect that to, other than the fact that if you're doing service mesh across the WAN, you've got WAN style latencies, I would expect that to go fairly well.
So we got about 15 minutes left. One of the other topics was, you know, as this data is being generated and tracked, the need to expose that on a public dashboard. Is that of interest to anyone? Is that like an activity of interest to anyone on this call in terms of doing it? I will. Yeah. If not, I will find some folks. Like we'll do it.
Awesome. Yeah, I can ask around. For example, in our team, I think I'm not pronouncing his name properly, but yeah, I can ask his team to see if they are keen on something of this sort. Let's see what they say.
Nice. Yeah, please do. Good. Well, there are a couple of other things that I think we might leave for another meeting. Zach had asked the question I think Nibendu had spoken to, like, what, given kind of a prelude to what it is that adaptive load control, some of the things that it's intended to be able to answer, and answer on an ongoing basis. So the concept of like continuous automation, or I'm sorry, continuous optimization, is in scope, kind of in focus of this topic.
Does that exist somewhere on like GitHub that can be checked out, or is that kind of just in the design phases right now?
The design is there and sent out for kind of review.
Okay.
Implementation isn't too far away. Actually, that's kind of what we, I think that's what the topic was kind of intended to be. I mean, if for nothing, I'll send you a couple of diagrams that explain. Actually, Zach, again, like it would be really good for you to get your and the rest of your teams or what have you, just perspective on whether or not that's actually helpful to you. And if some of the questions that we think that this adaptive load control capability will answer, if those are actually questions that you guys have. So yeah, so this is, you might not think it an ideal response, that it isn't an off-the-shelf capability, but actually maybe it is ideal because the input that you would give would change it. There's a collection of open source contributors that are about to go write this. So
Cool. Yeah, I'll definitely check it out.
anybody have other topics for today? There's a brief note that I wanted to make with Prashi. So Prashi and I were catching up earlier today. I'm pleased to see you, Prashi. So thanks for coming on the call. There's Prashi, I'll send you a link to there's an open issue that has to do with the design of the performance of the performance benchmark dashboards and exposing a bunch of the performance data. We're looking to do that. This is just kind of an example of a very simple dashboard. We're looking to do that type of a dashboard, basically what we were just talking about on this site, and helping tell people about what they can expect. And so Prashi, little did you know that by joining the call, you might be asked to do some things here. So. Okay, very good. Anybody have anything else for today? Anybody want to comment on future topics? This is kind of what we've got lined up. Could be really good to do. These two items I think are probably juicy and come with some demos. So these could be fairly intriguing. So one of those is about the adaptive load control thing that we just talked. The second one is about the beginnings of distributed performance tests. So load generation from multiple locations, not just against multiple endpoints at the same time, but multiple locations at the same time, or sourced from multiple locations.
Yeah, I can maybe send out the spec for review before we meet next time, so everyone can take a look and we can have demos or.
Nice. All right, that's a wrap for today. Nice to see everybody.
Yeah, awesome. Thanks for your time, guys.
Thank you.
Thank you, Zach. Thank you, Ed. Wow.
Cheers.
Thanks,
Bye.
everyone. Bye.